Roosa Joensuu from our Circular Aviation Lab that we have organized in the Center for Sustainability Circular Industries Hub. And yeah, that was a great collaboration between both industrial partners and also the two universities, Delft and Leiden. We had some collaboration also from Erasmus on this topic, and I think it became a very interesting lab with lots of interesting graduation theses. And Roosa is one example, and she will talk today about critical raw materials in aviation. And yeah, without further ado, I would just like to give you the floor, Roosa.
Yes, thanks a lot for the introduction. I also want to mention that I really enjoyed the lab, so thank you as well for everyone who was organizing the lab. So as was mentioned, I'm going to talk about critical raw materials in aviation. That is my thesis topic as well, and I'm still working on my thesis, so not too many difficult questions, please. And I also want to keep it quite high level today. I'm not going to dive into super details of materials, but I would like to still see people thinking about new things. Maybe you can also find a new perspective today. And let's see. And I'm going to start with, if I can get control of my presentation again. Yes, here we go. I'm going to start with asking you, what are critical raw materials? So unfortunately, I can't see you. I would really like to see if there are some hands raised, if someone already has an answer to this. I think some of you might have encountered critical raw materials in your studies or in your work. But if anyone would like to speak up and say something, please do so. Is there anyone who is willing to say anything? Okay, seems quite quiet. That's fine. We can then continue with this. So this is actually a question that I'm going to walk you through now. So we will take a look together at what critical raw materials are and how they are assessed. So how exactly is criticality defined? Well, first of all, there is no single global definition for critical raw materials. There are, however, two main aspects that apply. They are usually materials that are economically very important, and these materials have high supply risks. And of course, if you look at this, you can already see why there is no single global definition. The supply risks really depend on where you are on the planet. Which materials do you have available at the location that you're in? And same goes for the economic importance. Of course, there are some sectors that are really important for everyone in the world, but different countries are also focused more on different industries. And because we are in Europe, or at least I am, I don't know where you guys are at the moment, but I'm going to focus on the European assessment framework. And luckily, it's really simple. It has the two main aspects in a graph. You have the y-axis, the supply risk, and the x-axis, the economic importance. And here, this is a very simple form of the actual graph, but you can see the points A, B, and C, and you see the red dotted threshold lines. And the C point here is considered critical because it exceeds both of the thresholds. A and B are not yet at the critical point according to the European assessment framework. And here I have a picture of what the most recent assessment looks like. I'm not going to go into super details. There's a lot of information in this graph, but you can see here the supply risk on the y-axis again, the economic importance on the x-axis. And you can see that the blue dotted materials are not considered critical, but the red ones are. And there are quite a lot of them already. There is 1 point or 2 points actually, that I would like to point out to you to look at. So you can see on the supply risk axis, if you're going all the way up, you can see the LREE and HREE. These are the rare earth elements, and we will look at them later, but they are quite interesting materials. I'm also researching those. So keep an eye on those. Now, if we're really looking at the supply risk, then where do these materials actually come from? That's the question we have to ask ourselves. And this is again from a European perspective. So this map is based on where these materials are imported to Europe. And I would like to now bring your attention to China, because China has a lot of these materials and a lot of the processing of the materials goes through China. And again, if you're looking at the list there, you can see the rare earth elements popping up again, with 99% and 98% of the imports in Europe, or the shares of these materials, coming from China. And this explains why the supply risk is so high. If there are, well, there have been some geopolitical tensions before, and some are ongoing, of course, and that increases the supply risks at the moment. The other ones, you can take a look at these again sometime. I'm not going to go through all of them. I'm going to move on to the next point. So we've discussed now the supply risk aspect, and now we're going to the economic importance. So in what applications are critical raw materials used? And they are here in Europe often used in strategic sectors, also in other countries and other locations. And these sectors here, based on the European framework, are usually defined as the renewables and energy sector. We have the e-mobility sector and defense, sometimes also defense and aerospace. But here we're mainly looking at, again, the defense perspective and not really commercial aviation. So those two things I would like to here mention again, those two things, let's keep them separate. I will come back to that later as well, why I want to keep them separate. But of course, the materials don't just go into these sectors. They are used in components that are then used in the sectors. So I want to bring this now one level down. What are the components where we use these materials, and how are they applied in the sectors? So here I have some icons for you. The first one being a magnet. So in wind turbine generators in the renewable sector, also in electric motors, we have so-called permanent magnets, which contain a lot of rare earth elements. Here it comes again, the rare earths. We also have batteries that contain cobalt, lithium, also necessary in all of the strategic sectors mentioned here. And we have electronic equipment. Here we have, for example, boron and silicon in semiconductors. These are also used, these components, across all of these sectors. That means that these materials are really important to us and our economies, and especially to us when we are shifting towards a more sustainable future. This brings me to now the problem itself. This is quite a good graph in my opinion. I'm going to explain it a little bit. I stole it mainly because the colors are really nice in my opinion. It's from McKinsey. And this here shows the global lithium supply and demand. So lithium is actually supplied from ores, so mined, and also through the lithium salts, where it's extracted from the salt deposits. And here you can see the black line, the dotted one, and the normal line are showing the demand of lithium from now to the future, towards 2030. And we have the different blue shaded areas that show the supply. You can see that the demand is increasing at an insanely fast pace. And you can see here that the darkest blue area, the confirmed supply, is also increasing from the current supply. But by 2030, we also need other forms of supply than the currently confirmed one to actually meet the demand. And here we have the secondary supply as well. So through recycling, we have a little bit of lithium supplied through that. And then we have the light blue shaded area, additional early stage supply. And here I want to point out that that means that these are not confirmed yet. These are new sources of lithium from the ores, from the salts, that have not been confirmed. So we don't know what the quantities would be. We don't know when exactly it would be feasible to extract lithium from these sources. So And then we still have that gray area of unannounced supply. So supply that that doesn't actually exist yet. We don't know if we can meet this supply. And to me, this graph shows the problem itself. We have this increasing demand of materials. We have lithium for batteries across all of the different strategic sectors. And we are not sure how we're going to supply this lithium. Here I have the question, how are we going to enable this transition towards a sustainable economy? And how are we going to do it now, today? Because this is not just a problem for 2030 and 2050. We have to start thinking about it already today. So this is a lot to think about already, and that is why I would like to just focus on one sector. This is the sector that is close to me. This is what I'm looking at, researching, and I was also participating in the Circular Aviation Lab. So we're going to look at the aviation sector. So we're not going to worry about the other sectors for now. We're going to leave those to do their own thing, and we're focusing now on the mobility. And I previously mentioned that usually aerospace is there together with the defense sector, but I want to challenge that thought a little bit. The e-mobility sector is usually only seen as automotive, so personal vehicles. But if we're looking at mobility, that's a lot more than just cars, right? We have the maritime sector, we have aviation, transport of passengers, we even have transport of cargo. So why only limit ourselves to the automotive sector? Especially if we're looking at aviation and maritime, for example, that really need to undergo a change towards more sustainable energy sources. These sectors are transforming, and we need to see how they are able to do that. So the future of sustainable aviation, it is changing. We are shifting from kerosene to other energy sources. There are new fuels, new propulsion systems. There is a challenge in the design. In order to become sustainable, we need to still carry a lot of energy with us to take off and fly. Aerospace design is usually focused on lightweight designs. And unfortunately, kerosene is really good in this aspect. It has a very high energy density, so we can carry kerosene with us, but we can't carry other energy sources like batteries or hydrogen with us in the same way. So there is a challenge still there. The first step towards sustainable aviation is through sustainable aviation fuel. This is the easiest solution because it is close to kerosene. We can use current designs and materials. Sustainable aviation fuel works in small, medium-sized, and large aircraft. But here I would like to point out that this critical raw materials aspect and these materials that we're using, they're not only a problem for this future aviation. They're already a problem in current aviation. In current jet engines, we're using titanium and tungsten in the turbine blades and the compressor blades. So they are alloying elements that we use to produce current jet engines. And of course, if we're shifting towards sustainable aviation fuel, we're still using these same engine designs. So we will still be using titanium and tungsten as materials. And these materials are already critical. So there are already some challenges. This is already a problem. But now that we are transitioning towards other means of transport, towards other fuels, the problem is also changing a little bit. And you can see it here when we're looking at hydrogen and electric aircraft. For both of these, we need new designs and new materials. Hydrogen and electric aircraft are mainly applicable now in the small and mid-sized aircraft. So large aircraft, unfortunately, is not yet possible. Maybe in the future, we can look at the Flying V and even bigger types of the Flying V. And what exactly is changing here? Well, for hydrogen, we need fuel cells, unless we are doing hydrogen combustion, but otherwise we would be using fuel cells. And to produce fuel cells, we need cobalt and platinum. So we need more new critical raw materials that haven't been used in the aviation sector before. at least not to the extent that the future aviation will require. We also need batteries, which include lithium and cobalt. You remember the graph with the lithium demand and supply, how difficult that will be to meet already by 2030. So this is a problem that is growing. And we also have electric motors. And for electric motors, we will need rare earth elements. This is the materials that come from China with the really high supply risks, as you remember, hopefully, from the previous slides. One of the rare earth elements that is often mentioned for these magnets is neodymium. Neodymium iron boron magnets are some of the most common permanent magnets used in motors. And why am I actually bringing this up as something that I compared to the automotive sector before? Well, that is because the automotive sector is actually using these same components, fuel cells, batteries, and motors. And now the aviation sector, if we're shifting towards hydrogen and electric aircraft, we will also be needing the same materials and the same components. Are we then here competing, or are we working together towards a more sustainable future? So shifting towards sustainable energy sources is not only a design challenge from the perspective of lightweight design, how are we able to take off with these aircraft and actually fly, how are we supplying enough energy for the duration of the flight. But there's also the new challenge of how are we supplying the materials to actually be able to manufacture the components and use these aircraft. Now I've given you a lot of problems, but there might be also some solutions here. So how can we manage this future? One of the key things I want to mention here is the design for circularity. So here you can see the graph where we have the resources come in towards the production phase. And in the production or the design phase, we can already think of how we're going to reduce the material demand, material use, if we're going to substitute the critical raw materials to something else, what kind of material combinations are we using? Then we can come to the use and consumption phase. And it doesn't mean that we need to throw the materials away and waste them after use. We can hopefully reuse some components, repair and remanufacture them, or recycle the materials at least. All of these strategies actually help to reduce the demand of critical raw materials, materials in general as well. And they also help to reduce the supply risks of materials because we in the European Union are less import reliant and we can actually supply our own materials. However, how this applies to the aviation sector is still a bit of a question mark because the requirements for the components and the materials are high. Aviation is all about safety, so we have really high performance requirements, really high safety requirements, and we have to be sure that even after the use of a component, it is still safe to be used somewhere else or again in the aviation sector. So not all of the strategies apply to all of the components across all of the sectors. That is something I want you to think about. How can we apply this in the aviation sector and to other sectors as well? And how can we think with these circular strategies when we are designing or using different materials and components? Now, I'm not sure if you want to answer this question, but we can also discuss it in the question round. What are your key takeaways from this? I have a list of my key takeaways for you. I'm going to show them now, but I would really like to hear what you as the audience, what you think, what you have maybe learned from this. But I'm going to show my key takeaways for you first. So first of all, the critical raw materials. The problem is the urgency in demand. We are going through the energy transition. We're going through this transition towards a more sustainable economy, and we're doing it now. We need the materials to support this transition. Second of all, we have the aviation sector that is undergoing a change in energy source and components, which also leads to a change in the materials that we're using to produce these or to make these propulsion systems. And thirdly, when we're looking at the circular economy strategies, are we designing to meet the requirements of the product, or can we rethink the design requirements actually? can we already think how can we use recycled materials in our design? How can we design for the circular strategies instead of just trying to implement them for already existing components where it might be a bit more difficult? So thank you all for joining. Thank you for listening to the presentation. I'm gonna stop sharing the screen because I would like to see you as well.
Good. Thank you, Roosa. I see a lot of virtual applause, but I'll also give some real applause. So thanks for your presentation, Roosa. Yeah, any questions already popping up with people, or? I don't see any hands raised, so I can just kick it off maybe. Or there's here Janneke. Janneke, please.
Oh, sorry, wrong button. I think David Peck already had some questions before me. Or
oh, yeah, that was in the chat, but go ahead, please, Janneke.
Yeah, you go first because I'm supervising this, so I'm going to be quiet.
Yeah, I have a small question about the electric fueled planes. Is that going to be a thing? I thought it was like unfeasible to make electric planes anyhow. Gets too heavy batteries.
Yes. So
can you maybe explain it a bit further?
Yeah, I'm speaking here, I have to say, from my perspective. Some people might think differently, but yes, so the weight is a problem. With current batteries and what we can manage with the energy densities, we can only have small aircraft. So really general aviation, two-seaters. So nothing that will drastically change the way we fly. It's more for hobbyists, for training of pilots. Maybe in the future, if a new battery chemistries develop the way we would like to see them develop, it could be possible to extend electric aviation to bigger sized aircraft, to mid-sized. Personally, I don't think it will be possible in large aircraft, but that some people are more hopeful than I am.
Okay. I think what you can see now is a huge push for small taxi-like electric planes for small distances, and it might be a thing like when you have new forms of communication, it doesn't mean that the old disappears. It just has a new niche, and I think that might be the same here. That you might actually add planes to the mix instead of just exchanging regular planes with electric planes. So there's a lot of companies now developing and already on the market electric planes for small distances with, let's say, 10-seaters or something like that. So you see a lot of that, but probably indeed if you go for the, let's say, the bulk of the market, like the Boeing 737, which is kind of the bulk of all planes that fly around. That's a long way from being electric, and everybody is now aiming for hydrogen for those types of planes that are so that's the idea for the future there. Yeah.
One thing I'd like to mention here, I'd like to challenge that a little bit, because what you mentioned, kind of the urban air mobility and switching the means of transport that we're using to flying short distances with electric planes. If we're looking at, again, from the critical raw materials perspective, that just means that we are shifting to using more of these critical raw materials. The demand is increasing. So in a way, are we actually doing something that is more sustainable, or are we doing something that requires even more resources that we already don't have?
That is exactly the question, and indeed that's a very valid question. So if it's just on top of what we already have, then does it solve any problem at all? Yeah. Thanks.
Yes, thank you.
Jaco?
Yes, thank you. Well, thank you for a nice and interesting presentation on a very nice topic. And actually, I have a question that also touches upon this one. So I'm not fully sure what the kind of research questions were that you have asked yourself, so that set the boundaries of what you can do, of will do. but you move somewhere to, well, managing the future, then you talk actually about strategies or design strategies, but how that will work out depends very much on how the future will look like. So I was missing a bit of a trend analysis. So we're having that discussion now, and I was missing kind of scenarios, because we don't know how the airline of the aircraft of the planes will develop. And we know, well, as we know that we have to reduce our fossil fuels drastically, it may also be that if it wants to become a sustainable future, we have to reduce our flying as well, just to keep it manageable. But I didn't see that back in anything of what you said, or I may have missed it because I was slightly distracted at a certain moment. But can you say something on that?
Yes, I indeed did not include that. That's a good point, maybe also to include that in the future to show that. That is something that aviation sector is growing. So there is a growth in flying in general, but that is also, of course, more on the medium-sized and large aircraft, not necessarily looking at the general aviation sector. And indeed, the electric aviation, speaking only of battery electric, most likely will only affect this small general aviation sector and not really the commercial ones. If we're looking at the commercial aviation sector, there is a change or there is a plan to shift completely to hydrogen and sustainable aviation fuel. So to get out of kerosene completely. That would still mean that the large, bigger aircraft, I think that's about 15% of the market would be flying on SAF. And the rest, either SAF or hydrogen. Is there enough hydrogen to support all of this? Another question, interesting to ask. But the trend line is clearly going towards SAF flights supported by hydrogen in the medium-sized aircraft.
Yeah, but it's still say the technical, say the innovation supply side. It's not yet linked to any demand side or demand side regulation or demand side management or demand side regulations. So that may actually set clear limits on how far we can go. I have similar discussions also on plastics. It's so difficult to collect and sort that out. But if you would set regulations that you reduce the diversity in the plastics that are collected, it becomes much easier to recycle it. So this is very much a systemic issue at the same time, which is more than actually more relevant than you're actually now suggesting, in my view.
Well, if I can just jump in here, and we've discussed this, of course we have, because as I put in the chat, this is a very good industrial ecology perspective. You know, let's understand it in a wider sense. I think what I was going to write in the chat, but I'll say it, and this is something Rosa and I and Irene have discussed. This whole thing about electric aircraft, critical material demand, I mean, in that sector and industry and in the literature, including industrial ecology literature, is pretty much a blank space. So actually, it's all so many dimensions that are so new that doing really interesting what I would call industrial ecology type analysis that we've seen, for instance, in automotive or in EEE and in mobile phone. Rennie and I have done loads of graduations with this sort of thing with KPN, for example. We're not at that stage in this sector. It's the data just isn't available. The information is not available. Of course, I'm going to defend my student. A graduation can only do so much given where we are. I mean, I think this is 2 or 3 PhDs worth. So I'm kind of defending Rosa a little bit here on this, that it's a very early stage, but the answer was correct she gave. Yeah, this is future work.
Okay. Thank you, both of you.
Okay. Thanks. Elise?
Yeah, I had a question actually to Rosa. One is about the time frame we are looking at, because if I remember correctly, it takes a very long time to design a new aircraft. And I was wondering, so the demand of critical raw materials is also I mean, the time frame we're going to look at is also going to be different than the time frame we're looking at for electric vehicles or cars. Is it something that was included in the graph, the blue graph that you showed with the curve growing exponentially, or is it already taken into account in that for the aviation sector, but also for the offshore maritime sector, where the demand also will possibly be on a different time frame?
Yes, that's actually a really interesting question, because I don't usually see the aviation sector and the maritime sector included in the critical raw materials discussions. Yes, these are also kind of niche sectors if you're comparing that to how many electric cars are being produced every year. But they are not really considered, although there is also an interest from those sectors to look at this, because they will be competing for the same materials. From the time frame, this is also, I think that's also one of the issues, because of course we see this change in the automotive sector now. We already have electric cars going around. That's just only increasing in a very short time. Whereas for the aviation and the maritime sector, the change takes longer. So they will only start entering this demand a little bit later.
Yeah.
If we're looking at, for example, hydrogen aircraft, that will have something by 2030, something and even more hydrogen aircraft by 2050. That means that those fuel cells for the hydrogen aviation will only be needed a little bit later. At that point, the question is it still possible to supply them at all? Have we already passed the point where that is, have we already went past the main problem point and then we don't know what to do anymore? That's something I don't know. But I think there is definitely interest to research this more, looking at the aviation and the maritime sectors as well, looking at how the time frame matches with the current demand estimates. And also maybe a little bit coming back to the previous question on the regulations as well in the aviation sector. Well, currently there are no regulations limiting specific energy sources, for example, as far as I know, completely. So the regulations, of course, are developing, but and there will be, yes, kerosene tax, for example, but will flights be limited? Will the aviation sector itself be limited in the materials and the designs that they have? I don't know yet.
Just maybe to add to that, I think that it also depends on how this will be implemented, because indeed airplanes have a very long lifespan. So if you want to introduce a new technology only in new planes, it will take a very long time to actually replace the whole fleet. But what you can see now, for example, in hydrogen, in these let's say the bulk of the market, the Boeing 737 type of aircraft, is that you can see that the companies that are focusing on that are focusing on refitting. So they're basically using the airplane as it is and refitting that with electromotors and fuel cells to actually make that work. Because else it would be way too slow to actually make a difference. So in that sense, it might go quicker for hydrogen at least. I'm not sure whether that's and for the electric planes, like I said, it's a different market, and whether that will kick off and whether that will just be an addition to the current aviation sector is a question, a big question mark, I think. But yeah, it depends on, in that sense, I come back maybe to Jaco's comment. It depends on the scenario that you think will that might be plausible. So it might be useful to make indeed these different scenarios for the future. Yeah.
Thanks. And I had a second question, if I still can.
Yeah.
I was wondering if reuse, recycle, remanufacture is already applied in aviation with, what you mentioned about liability and safety, and how much is it already done?
Yes,
is it something that's already started and that's going to be increased in the future? I mean, how do you do with the regulations and stuff?
Yes, that's a really interesting question. So in the aviation sector, of course, a lot of the important components are very crucial, so they are monitored really well, and they are repaired as much as possible to extend the lifetime of the aircraft as well. And also for the value of the component itself. If you're looking at the jet engines, you would rather try to repair it and monitor it than completely change it. For them, how much is actually being remanufactured and repaired otherwise, not really that much, especially on a structural level. Yes, repairs are done, but remanufacturing of components is not really done, or repurposing even to other sectors. Something that is done a lot is the interior cabins, so that those materials and parts can be repurposed somewhere else. But the aviation sector, I think, often mixes up a little bit, like the repairs with the other circular strategies. So I think in the aviation sector, there is a lot of the times an attitude that, yes, we are doing a lot already because we're repairing so much. But that is only for that one specific aircraft and to extend its lifetime, and not really to have the component or the part itself circulate for longer.
Okay, thank you.
Thanks. I don't see any hands raised, but I would like to ask you, Rosa, so your work is not completely finished yet, I understand, but what would of course be very interesting is to have a look at the quantities of materials that we would need in different scenarios. Maybe I'm not sure how you will approach that, but and also comparing that to things like the materials that you would need in other applications like cars. And that's especially interesting, I think, because the European Commission is now preparing a Critical Raw Materials Act, and one of the key things that they mention is they want to focus on priority applications. And then the question is, of course, what are these priority applications? So it would be interesting to have an idea of the numbers, and also about whether, well, would also be interesting to have a look whether this would be a priority application from the EU perspective.
In the chat, I'd already covered this. I don't think demand from aerospace is going to make much difference at all when compared to low carbon energy generation, other forms of electric mobility, digital. By the time we've taken all those, all our standard assessments that we've been involved in, you and I, Renee, and other people, it's going to be on the pie chart. It's going to be a very thin slice of almost, the single line type slice. So I'm not sure that's highly relevant, although we need to understand it. I think that's your point, and I agree. I think the really interesting point, and Rosa touched on it in the beginning, and I've been seeing it a lot. I've done some work with NATO, and I'm now talking with other defense agencies as well. It's the aerospace or stuff that flies, including drones, and I mentioned that as well in the chat. That will go high on the policy agenda. So critical materials for aerospace for defense application will be top priority, might even go above other applications, because defense and security trumps all sometimes. So that might be an interesting dimension to understand, and I don't fully understand that yet. So that's something I'm interested in.
Yeah, great point.
From my side, just maybe you can, maybe I can come talk again in a few months, and then we can see an update on the progress.
Yep, would be great. Thanks. Any other questions? I don't see any hands raised. If not, then I would like to thank you, Rosa, for your presentation. I wish you good luck with finalizing your work. Looking forward to see the results also of the work. And yeah, I think it just highlights another interesting area where critical raw materials are of crucial importance. And like Dave said, I think that this will be one of the main priorities also, especially if it comes into defense applications of the Commission in future years. So let's see what happens there. And thanks again for your presentation, and hope to see you all with the next edition of this series of talks.
Thank you.